We are in the Water Quality Laboratory at the Department of Civil and Environmental Engineering at Worcester Polytechnic Institute. Right now on the magnetic stirrer I've got a bottle of clean seawater collected from the Florida Keys just a couple of weeks ago. And what we're going to do is we're going to add about 1 milliliter, about 1/3 of 1% of one of BP's crude oils from its spill off of Louisiana in the Gulf of Mexico. So once we add that, we'll start the clock. And take a look at what happens once that oil gets into the water. If you look carefully, you can see that the oil is forming a large number of small droplets being spun about the by the magnetic stirrer. So we'll let that go for about a minute and stir up. Okay, that's 60 seconds. We'll stop the stirrer bar, and very slowly the oil droplets that are mixed in with the seawater, they make their way to the surface, just like they would from, say, a leaking underwater oil well in the Gulf of Mexico. That's 20 seconds. Most of the droplets, even though they're small, start to reach the surface. And you can see a small slick of oil appearing, half a minute. Already when you're looking, you can see that the water is fairly clear. 40 seconds. So now what we're going to do is add a little bit of dispersant. This is made by Nalco. This is Corexit 9500A. We're going to add it about 1 part in 25 compared to the oil. That's 40 microliters if you're keeping track. And what this lets us do is see what happens to the oil and how it behaves differently once we add some dispersant. The first thing that happens, you can see that the oil instantly races to the sides of the glass. And now it's starting to adhere to the glass. Let's turn the stirrer back on. It's been about a minute and a half since we first stopped that stirrer the first time. And we'll let that mix for a minute, just like we did before, and see if there are any differences. About 20 seconds. About 30. Forty seconds. 50. Okay, now like before, we've let it stir for about half a minute. We'll stop the stir bar, and we'll see if we notice anything different when you add a little bit of dispersant to BP's crude oil versus just the crude oil alone. Now this time when we stop the stirrer, when we have a mixture of dispersant and crude oil, instead of the crude oil going right back to the surface, this time much of it stays in the water itself. The water stays discolored. Many of the toxic compounds that are in the oil remain in the water instead of moving back to the surface where they could be skimmed. What's happening now is, because we're getting about 35 times more of the most toxic hydrocarbons in the crude oil staying in the water column, we're finding that the toxicity of the water is actually increased by adding dispersant to the crude oil. If the crude oil hadn't had dispersant in it at all, we would have far fewer of these most toxic compounds in the water column, where the animal larvae and spawning actually live and reproduction takes place. When we look at the total amount of oil that stays in the water compared to just using crude, once we've used the dispersant, that's over 100 times increase in the amount of petroleum that we find staying in the water. It's even longer if we mix for a longer period. So I'm going to let this go for about 1 minute. That's much shorter than you would have in the actual trip for this water moving from the bottom of the Gulf of Mexico, where dispersant is added to the oil leaking from the well and making its way to the surface. Same 1 minute. Once again, bring the stir to a stop and see how much more of the material returns to the surface. And once again, we're seeing the same effect. The stronger dark yellow color corresponds to the larger amount of toxic petroleum compounds that stay in the water column compared to just the crude alone.